Let's face it, we are swimming in data. But data alone doesn't give us answers. So how do we turn all those numbers into actual smart decisions? In this explainer, we're going to walk through the key steps that transform raw data into clear, actionable insights.
And this is the end goal. A dashboard like this one isn't just a bunch of pretty charts. It's clarity. It's the power to see what's going on at a glance so you can make smarter decisions faster. And the amazing part? It's all built on a few fundamental statistical ideas that we're about to break down.
So that's the big question, right? How do we get from a messy spreadsheet full of numbers to something this powerful and clear? What's the secret sauce? Well, let's pull back the curtain.
Here's the game plan. First, we'll get our heads around what data-driven even means. Then, we'll open up the basic toolkit every data person needs. After that, we'll become data detectives, looking for hidden clues. And finally, we'll learn a technique to see the big picture, even when things get super complex.
Okay, first things first. Before we can start crunching numbers, we need to lay down a solid foundation. Let's make sure we're all on the same page about the what and the why of this whole process.
You know, people often mix up probability and statistics, but they're really two sides of the same coin. Think of it like this. Probability starts with the rules and predicts what might happen. Like, if I have a fair coin, what are the odds of getting heads? Statistics does the opposite. It looks at what already happened, say 100 coin flips, to figure out what the rules are. Is the coin actually fair? In this explainer, we're firmly in the world of statistics.
All right, time to open up our toolkit. These are the absolute essentials of what we call descriptive statistics. Think of this as learning the basic vocabulary you need to make any dataset start talking to you. And we're going to start with an old friend, the mean. You probably know it simply as the average. It's our number one go-to tool for figuring out the center of our data. So simple, but so important.
And here you can see how it works, side by side. On the left is the formal math, but on the right is what really matters. You just add up all the scores, divide by how many students there are, and bam, you get one single number that gives you a snapshot of the whole class's performance.
But wait, the mean isn't the whole story. What if one student got a really high score and another got a really low one? That can kind of throw off the average. That's why we have the median. It's the person literally in the middle if you lined everyone up. And the mode, that's even simpler. It's just the score that shows up most often. They're just different ways of looking at the center of your data.
So knowing the average score is great, but it doesn't tell you everything. Imagine half the class got a perfect score and the other half failed. The average might be 75, but that doesn't really describe what happened, does it? That's where variance and standard deviation come in. They help us measure how spread out, or you could say messy, the data really is.
So how do we actually put a number on that messiness? Well, we use this formula for variance. Now, don't get bogged down in the math. All it's really doing is calculating the average distance of every single data point from the center. A small variance means all the data is clumped together. A big variance means it's all over the place.
Okay, so we've gotten pretty good at describing a single set of numbers. But you know where the real magic happens? When you start finding connections between different things. It's time to put on our detective hats.
Honestly, one of the best ways to find a connection is to just look for it. A scatter plot, like this one, is perfect for that. It lets us see if there's some kind of pattern. Just looking at this, you can already start to get a feel for it, can't you? It kind of looks like the more you study, the higher your score gets.
And these are the classic patterns we're always hunting for. Does one thing go up when the other goes up? That's a positive correlation. Does one go up while the other goes down? That's a negative one. Or is it just a random blob with no pattern at all? Getting a feel for this visually is super important.
Now, to make it official and put a number on that pattern, we use what's called the Pearson correlation. It's awesome. It takes that whole scatter plot and boils it down to just one number, somewhere between -1 and +1. +1 is a perfect straight line going up, -1 is a perfect straight line going down, and 0 is, well, nothing at all.
Okay, that's great for numbers, things like hours and scores. But what if our data isn't numbers? What if we're trying to compare categories? Like, is there any connection between a student's gender and the grade bracket they ended up in? We're going to need a totally different tool for that job.
And that tool is the chi-square test. It sounds a little intimidating, but it's really just a simple 4-step process. First, you ask your question. Then you organize your data into a simple table. The test then compares the numbers you actually saw with the numbers you'd expect to see if there was absolutely no relationship. The bigger the difference, the more likely something real is going on.
And for our last detective tool, we've got ANOVA. This one lets us ask a really cool question. What if we want to see if a number, like study hours, changes across different categories, like our score brackets? ANOVA is built for exactly that. It tells us if the average study hours are meaningfully different from one group to the next.
Okay, this looks like a lot of numbers, I know. But here's all you really need to focus on. See that F score? That's our key number. Because it's way, way bigger than the critical value next to it, we've got our answer. A big flashing yes. There is a real, significant difference in study hours between the groups. The data has spoken.
All right, for our final section, we're going up against the final boss, complexity. What happens when you don't just have a few variables, but dozens, maybe even hundreds? How in the world do you find the pattern in all that noise? We're going to look at a seriously powerful technique for this called Principal Component Analysis, or PCA.
So here's the problem that PCA was invented to solve. When you have tons of variables, a lot of them are kind of redundant. They're telling you similar things. All that overlap just creates a ton of noise, and it can make it almost impossible to see the true patterns that are driving everything.
And this is the magic of PCA. It is so clever. Look, we have two variables here, height and weight. They're obviously related. What PCA does is find the single best direction, that red arrow, that captures the main relationship between them. It then creates a new supervariable along that line. It's like combining two variables into one that has the best of both.
And how good is it at this? Unbelievably good. In this example, that one new supervariable we created captures 99.6% of all the information from the original two. Think about that. We cut our complexity in half, but we lost almost nothing. Now imagine doing that with 50 variables and shrinking them down to just 2 or 3. That's the power of PCA.
So there you have it. From the simple basics of describing data to the detective work of finding hidden connections and all the way to the power of taming real complexity, you now have the fundamental toolkit. So the only question left is, what story are you going to uncover first?